to my YouTube channel. My name is Darlington Nkwasi, and today I'm going to teach you how to properly select VRF Y-branches without software. Previously I created a video on how to properly determine the pipe sizes of VRF equipment without software. I also created a video on how to verify the results with LATS hvac, and that's because I used LG products for those videos. But in this video I'm going to use Hitachi products, specifically the Hitachi Set Free Sigma CNCQ series. Okay, I'm going to put the links for the previous videos in the description, okay, so you can check them out. So to properly select VRF Y-branches without software, first you have to draw a tree diagram containing the indoor and outdoor units with their capacities. Second is to determine the total indoor units capacity on each branch. Third is to determine the pipe sizes between the outdoor units and the first Y branch, between Y branches, and between Y branches and indoor units connected to them. Then the last step would be to select Y branches based on the two previous steps and information from the engineering product data book and or the product catalog. This step is actually very important. It's very important to always look up the engineering product data book or the product catalog. This is the drawing we're going to work with. It's a residential building. Let me zoom in properly so that you can see it clearly. So it's a residential building. It has a master's room, a children's room, a lounge, a living room, two bathrooms, a dining, and a kitchen. There's a cassette units in the dining room. There are two cassette units in the living room. There's a wall-mounted unit in the lounge. There's a wall-mounted unit in the children's room, and there's a wall-mounted unit in the master's room. I did not cool the kitchen, and I did not cool the two bathrooms, of course. I deliberately removed the equipment schedule so you cannot see the capacities of the indoor units and the outdoor units here in this drawing, but you'll see them in the tree diagram that I'm going to show you later. Alright, so this is the drawing we're going to work with. What I'm going to do next is draw the tree diagram that will show how the pipes are routed from the outdoor units to the last indoor units here in the living room. Before we begin, there's something I quickly want to show you. Here I have 4 tables, and these tables are the tables that would enable us select the right Y branches for the VRF system. Okay, these tables apply specifically to Hitachi products. That's the CNCQ series. Okay, precisely. The first table is the table that would enable us select the right outdoor units Y branch or the right piping connection kit. Because I'm dealing with Hitachi products, I'm going to call the outdoor units Y branch piping connection kit, while the indoor units Y branch would be called multi kit. Okay, so for the first table, for a standard Hitachi VRF system with a top flow discharge, okay, that's the CNCQ series. That's what I'm referring to. Okay, the maximum outdoor unit capacity is 24 HP for a single module. Okay, if you want to go higher than 24 HP, then you have to combine like 2 or more modules. Okay, so for example, if the outdoor unit capacity is between 26 and 34 HP, then you have to combine 2 modules. Okay, and the right piping connection kit to use is M30 SNQ. If the outdoor units capacity is between 36 and 48 HP, then you have to combine 2 modules again, and but this time the right piping connection kit to use is M46 SNQ. If the outdoor units capacity is between 50 and 54 HP, then you have to combine 3 modules, okay, and the right piping connection kits to use, this time you have to use like 2. Okay, so there are M30 SNQ and M46 SNQ. If the outdoor unit capacity is between 56 and 72 HP, then you have to combine like 3 modules. Okay, this time you're still using 2 piping connection kits. Okay, but there are M30 SNQ and M68 SNQ. For the outdoor unit capacity that is between 74 and 96 HP, you have to combine like 4 modules. Okay, this time you'll be using 3 piping connection kits. That's M30 SNQ, 2 of that, and 1 of M68 SNQ. All right. So that's for table 1. Although in this video the outgoing capacity is 14 HP. That's for the drawing that I showed you earlier. The outgoing capacity is 14 HP, so we will not need this table. For the second section, we have two tables. Okay, the first table would enable us to select the right multi-kits for the first branch. Okay, while the second table is the table that would enable us select the right multi-kits after the first branch. So for the first table, if the main piping is greater than or equal to 100 meters, then we have to use this part of the table. Okay, but if the main piping is less than 100 meters, then we have to use this part of the table. Okay, for example, for the first part here, if the outgoing capacity is between 8 and 10 HP, then we have to use E162 SN. All right, and if the outgoing capacity is between 56 and 94 HP, then we have to use E682 SN. For the second part, if the outgoing capacity is between 8 and 10 HP, then we have to use E102 SN. And if the outgoing capacity is between 74 and 96 HP, then we can use E682 SN. For the second table, that's for multi-kits after the first branch. If the total indoor capacity is less than or equal to 15.9 kilowatts, then the right liquid pipe size to use is 9.52 millimeters, while the right gas pipe size to use is 15.88 millimeters. Okay, if the total indoor capacity is between 16 and 25 kilowatts, then the right liquid pipe size to use is 9.52 millimeters, while the right gas pipe size to use is 19.05 millimeters. If the total indoor capacity is between 25 and 33.5 kilowatts, then the right liquid pipe size to use is 9.52 millimeters, while the right gas pipe size to use is 22.2 millimeters. And these three ranges fall under this classification. That's E102 SN. Okay, and we can go on and on until we get to E682 SN. That's where the indoor capacity is between 207.2 kilowatts and 349.5 kilowatts, and these are the right pipe sizes to use for the three ranges under this classification. The last table is the table that would enable us determine the pipe sizes between the multi-kits and the indoor units connected to them. What I'm going to do now is show you where I got these tables. So this is where I got those tables. That's from Hitachi's Set Free Sigma product catalog for VRF source coding only type CNCQ series. Okay, I'll just quickly rush to the page where I got the tables. Alright, so I got the tables from this page. Okay, so you can see the piping connection kit, and you can also see the multi-kit. Okay, so this is where I got the tables. For the last table, I got that by looking at the specifications of the indoor units. All right, this product catalog is easily accessible. It's something that you can easily find online, so you can just Google it. This is the tree diagram for the drawing that I showed you earlier. As you can see, it shows how the pipes are routed from the outdoor units to the last indoor units. Okay, and it also shows the length of the pipes as you go. So what I'm going to do now is calculate the total indoor units capacity on each branch. So we'll call this branch A, we'll call this B, we'll call this C, D, and E. Alright, at branch A, the total indoor units capacity is this plus this. Okay, so that's 16.0 kilowatts. At branch D, the total indoor units capacity is 16 plus 8.0 kilowatts again. Okay, and that'll give us 24.0 kilowatts. Okay, at branch C, the total indoor units capacity is 24 plus 3.6. Okay, that's this. All right, and that will give us 27.6 kilowatts. All right, at branch D, the total indoor units capacity is 27.6 kilowatts plus 5.6 kilowatts. Okay, that's this. So come here and write 33.2 kilowatts. Okay. At branch E, the total endurance capacity is 33.2 kilowatts plus 4.0 kilowatts. All right. So that will give us 37.2. So we'll come here and write 37.2 kilowatts. All right. So with that, we have calculated the total endurance capacity on each branch. So what we're going to do next is calculate the sorry, let me just circle this. So what we're going to do next is calculate the pipe sizes between the multi-kits and the indoor units connected to them. To determine the pipe sizes between the multi-kits and the indoor units connected to them, I said we would use this table. So at branch A, the indoor units connected to branch A have a capacity of 8.0 kilowatts. Okay, so let's start with this one. The capacity of this unit is 8.0 kilowatts, and 8.0 kilowatts is between 5.6 and 16 kilowatts. All right. So we'll choose this. Okay. That's 9.52 millimeters on the liquid side and 15.88 millimeters on the gas side. Okay, so we'll come here and write 9 and 15. It's the same thing with this indoor units here. Okay, because this they have the same capacity, right? So I'll come here and write 9 and 15. At branch B, the indoor unit's capacity is 8.0 kilowatts. That's the capacity of the indoor units connected to it. Alright, so it still falls within this range. Alright, so write 9 and 15 again. At branch C, the indoor units connected to branch C has a capacity of 3.6 kilowatts. Alright, so write 3.6 kilowatts is less than 4.3 kilowatts. All right, so we're going to use this row. So come here and write 6 and 12. For the indoor units connected to branch D, the capacity is 5.6 kilowatts. Okay, and 5.6 kilowatts is of course equal to 5.6 kilowatts here. So we're going to use this row. That's 6.35 millimeters on the liquid side and 15.88 millimeters on the gas side. So come here and write 6 and 15. For the indoor units connected to branch E, the capacity is 4.0 kilowatts, and 4.0 kilowatts is less than 4.3 kilowatts. Okay, so we're going to use this row again. So come here and write 6 and 12. And with that, we have successfully determined the pipe sizes between the multi-kits and the indoor units connected to them. So what we're going to do next is determine the pipe sizes between the multi-kits themselves. To determine the pipe sizes between the multi-kits, I said we would use this table. At branch A, the total indoor unit capacity is 16.0 kilowatts, and 16.0 kilowatts falls within this range here. Alright, so the right liquid pipe size to use is 9.52 millimeters, while the right gas pipe size to use is 19.05 millimeters. So we'll come here and write 9 and 19. At branch B, the total indoor unit capacity is 24.0 kilowatts, and 24.0 kilowatts still falls within this range. Okay, so we'll come here and mark it again. That's 9 and 19. So write 9 and 19. At branch C, the total indoor unit capacity is 27.6 kilowatts, alright, and 27.6 kilowatts is between 25 and 33.5 kilowatts, alright. So the right liquid pipe size to use is 9.52 millimeters, while the right gas pipe size to use is 22.2 millimeters. So come here and write 9 and 22. At branch D, the total indoor unit capacity is 33.2 kilowatts, alright, and 33.2 kilowatts is between 25 kilowatts and 33.5 kilowatts. Alright, so the right liquid pipe size to use is 9 and 22 as before. I didn't mark it before, so I've marked it now. Alright, so it's 9 and 22, so we'll come here again and write 9 and 22. For branch E is the first branch. Okay, so we won't use this table. is what we're going to do next. We're going to determine the pipe sizes between the outdoor unit and the first branch here, which is branch E. We'll also maybe we should do that now to determine the right multi-kits, because we can do that from this table. Okay, so at branch A, the total indoor unit capacity is 16.0 kilowatts, all right, and 16.0 kilowatts falls under this classification. Okay, so the right multi-kit is E102SN. At branch B, the total indoor unit capacity is 24.0 kilowatts, and 24.0 kilowatts falls within this classification again. So the right multi-kit is E102SN. At branch C, the total indoor unit capacity is 27.6 kilowatts, and 27.6 kilowatts falls within this classification again. Okay, so write E102SN. At branch D, the total indoor unit capacity is 33.2 kilowatts, and 33.2 kilowatts still falls under this range. All right, so come here, right, E102SN. Under the classification. Okay, so it's E102SN. At branch E is the first branch, like I said. So we'll determine the right multi-kits from the product catalog. We'll also determine the pipe sizes between the outdoor units and the first branch, that's branch E. Now I have the product catalog open here, so I'll just go to page 10, because that's where the specifications of the outdoor units are. I'll zoom in properly so that you can see it clearly. Okay, so this is the outdoor units with a capacity of 14 HP. Let me scroll down to the place where the pipe sizes are. Okay, so this is where the liquid line is, and this is where the gas line, the low pressure gas line is. Okay, let me put this on full screen so that you can see it clearly. All right. Okay, let me zoom in properly so that you can see it clearly. Okay, so it's 12.7 millimeters, while the right gas pipe size is 25.4 millimeters. Okay, all right, so that's 12.7 and 25.4 at 14 HP. All right, so we'll go back to our slide and include that. So we'll come back here and write 12 and 25. All right, so what we'll do next is determine the right multi-kit at branch E. So determine the right multi-kit at branch E, I said we'll use this table. Okay, so we know that the length of the pipe between the outdoor units and the first branch is 30.9 meters, and 3.9 meters is less than 100 meters, and the capacity of the outdoor unit is 14 HP. Okay, that's 40.0 kilowatts is the same as 14 HP. Okay, so 14 HP is between 12 HP here and 16 HP, so we're going to use this part of the table and this multi-kit. All right, so we'll come here and write E162SN, and with that we have successfully determined the right multi-kits for all of the branches. So that brings us to the end of this video. If you enjoyed watching it, please subscribe to my YouTube channel, like, comment, because that helps with the YouTube algorithm. Also hit the notification bell, and I'll see you in the next video.